Welcome to today's deep dive. I'm so glad you're joining us for this one because today we're talking about something sitting in millions of homes right now.
Millions of homes and
That-
businesses, yeah.
Right, and it gives people this really profound, almost primal sense of security. But as we're about to explore, that security might just be an illusion.
A very dangerous illusion in some cases.
Exactly. So our mission today is to dive into the fascinating world of physical security. Specifically, we're focusing on the reality of safes. We want to know why some safes protect your valuables during catastrophic events like fires, while others just completely fail.
And, the critical engineering differences you really need to understand before you lock away your most prized possessions.
It's a topic that routinely catches even the most security-conscious people totally off guard.
Oh, absolutely. We have this psychological bias, right? We assume a heavy, imposing metal box automatically equals impenetrable protection against literally all threats.
Because it's heavy.
Right, because it's heavy. But
Yeah.
the physics and the engineering behind that box tell a highly specialized and very different story.
And to get to the absolute bottom of this for you, we are pulling from a massive stack of technical documentation today.
It's quite the stack.
It really is. We've synthesized professional locksmith operating guides, the Los Angeles City Department of Building and Safety electrical and fire testing lab manuals, some technical access control cost breakdowns, and even direct insights from master locksmiths.
It's an incredible wealth of insider knowledge.
It really is. Okay, let's unpack this.
Well, it really starts with understanding the extreme thermal environment of a structural fire. A house or an office fire isn't just a localized area of heat.
Right.
It's a catastrophic thermal event. It actually alters the chemical composition of everything it touches.
To put some concrete stakes on that, the Division of the State Architect Guidelines highlight this completely terrifying metric. A typical room fire can reach over 1,000 degrees Fahrenheit in less than 5 minutes.
5 minutes.
5 minutes. I want you to imagine your own valuables. Your passports, maybe large amounts of cash, birth certificates, or a hard drive with your family's entire digital history, just sitting in that exact scenario.
Yeah, paper auto-ignites at 451 degrees. Plastics melt at much lower temperatures than that.
So at 1,000 degrees, you are dealing with an absolute inferno.
What's fascinating here is that not all safes are created equal to handle that inferno.
Not even close.
The most critical distinction in the locksmithing industry is between fire safes and burglary safes. They serve two completely different and sometimes actually opposing purposes.
Break that down for us.
Sure. So fire safes are specifically designed and insulated to protect documents and cash from ambient heat. Their fire ratings are based on endurance and internal temperature.
Usually ranging from, 30 minutes to 2 hours?
Exactly. 30 minutes to 2 hours at extreme external temperatures, all while keeping the inside below that crucial 350-degree mark.
And these aren't just arbitrary marketing numbers either. The testing standards, like the UL 155 tests for fire resistance of vault and file room doors, which we found in the lab documents, are incredibly brutal.
Brutal is the right word.
They don't just put a safe in a hot room, they put it in a blast furnace.
Yeah, and in some tests, they heat it to over 1,500 degrees, hoist it 3 stories in the air, and drop it on a pile of rubble.
To simulate a floor collapsing during a house fire.
Right, and then they put it back in the furnace.
That is insane.
It's rigorous. But the engineering behind a fire safe is brilliant. They're essentially built like reverse ovens.
Wow.
The walls aren't just solid steel, they're filled with a proprietary composite material, often a gypsum-based amalgam.
And that insulation actually contains chemically bound moisture, right?
Exactly. When exposed to extreme heat, that moisture vaporizes into steam. The steam absorbs the heat energy in an endothermic reaction.
So it actively cools the interior of the safe.
Yes, keeping the internal temperature below the point where paper ignites.
It's basically sweating to stay cool.
That's a great way to put it. But that brings us to the dangerous misconception with burglary safes.
Where people equate sheer weight and thick steel with invulnerability.
Right. You look at a high-security burglary safe with a rating like TL15 or TL30, and you assume your documents are completely safe from anything.
And that assumption can be disastrous. Let's unpack those acronyms really quick. TL stands for tool resistant.
Correct. A TL15 rating means the safe is guaranteed to withstand 15 minutes of continuous aggressive physical attack by a professional safecracker.
Using heavy-duty tools like carbide drills, abrasive cutting wheels, pry bars.
And 15 minutes doesn't sound like a lot, but in the context of a loud, messy burglary, a quarter of an hour is an absolute eternity.
But, and this is the crucial part that really blew my mind, A safe built with solid 1-inch thick steel plate to snap a drill bit might not have any thermal insulation whatsoever.
None at all. Solid steel is essentially a thermal conductor.
So you are basically buying a highly secure oven. A 1,000-degree fire will conduct straight through that thick steel wall and incinerate everything inside.
While the safe itself remains perfectly intact.
Wow.
It's a perfect illustration of threat modeling. You have to ask yourself, are you protecting cash from a targeted heist, or are you protecting vital family documents from a house fire?
What about gun safes? Because those seem really popular.
Gun safes try to be a jack of all trades. They offer some level of fire resistance and tamper-proof locks to comply with legal storage requirements.
But they rarely excel at either compared to a purpose-built commercial vault.
Exactly. It really is about matching the safe to the specific threat you're trying to mitigate.
That's the exact reason why consulting a professional, rather than just guessing at a big box store based on how heavy a box feels, is so vital.
Actually, speaking of choosing the right protection, this deep dive is sponsored by West Point Locksmith. You can reach them at 310-295-4040.
They deal with this exact mismatch every single day. They really do. They are fast, reliable, and professional locksmiths serving all of Los Angeles. With 5-star reviews, they specialize in residential and commercial safes, fireproof safes, and vault security solutions. They're available 24/7 to keep your home, business, and vehicles secure.
And securing those valuables extends far beyond just the walls of the safe,
Right, it comes down to the locking mechanism itself.
which is often the most vulnerable point of failure, especially under the physiological and environmental stress of an emergency.
Yes, let's shift the focus to how safes actually lock, because there is a shocking detail in the technical teardowns from these professional locksmith sources. You'll see videos and documentation of consumer-grade safes, like your standard Sentry safes, being bypassed in less than 5 seconds.
Less than 5 seconds.
5 seconds to bypass a lock you trust with your passport and emergency cash. Usually by bouncing a rare earth magnet over a solenoid, or even just hitting the top of the safe with a rubber mallet while turning the handle.
It's a stark reminder that consumer convenience almost always trades off with actual security. If we look at the mechanical vulnerabilities of different locking systems, particularly during a fire, the landscape shifts dramatically.
Let's start with the oldest, most durable technology, the mechanical combination lock.
The classic rotating dial. They use a dial to align a series of internal brass or steel wheels, known as the wheel pack, with a specific set of notches called gates.
And once those are aligned, a metal bar called the fence drops in, and the safe opens.
Exactly. And because it's entirely mechanical, it's virtually immune to environmental factors.
There are no batteries to die.
No circuit boards to short out from an EMP.
And the extreme heat of a fire won't melt internal wiring because there isn't any.
Right. Thermally and mechanically, they are tanks. But their critical vulnerability is human physiology.
That is such an interesting point.
They require fine motor skills and exact precision. If your house is on fire, the smoke alarm is screaming, and the room is filling with toxic smoke, your sympathetic nervous system dumps adrenaline into your bloodstream.
Your heart rate spikes, your hands start shaking.
And trying to remember if you turn left past the second number 3 times or right past the third number 2 times, it becomes nearly impossible.
That physiological reality is exactly why the market overwhelmingly shifted to electronic or digital keypads. You just punch in a 6-digit code, the solenoid clicks, and you're in.
It requires zero fine motor skills.
Highly convenient, yes. But they rely entirely on batteries, delicate internal circuitry, and a plastic housing.
Which is a huge problem in a fire. If that safe is exposed to extreme heat, the internal circuitry can melt. The keypad itself can warp and fuse to the door.
So even if the internal fire insulation does its job and your documents are perfectly preserved,
The locking mechanism itself will fail permanently, leaving you entirely locked out of your own safe.
what about biometric locks? The fingerprint or facial recognition systems, they feel incredibly high-tech, like something out of a spy movie.
They are high-tech, but they suffer from the exact same electronic vulnerabilities, plus environmental false rejection rates.
Because of ash or soot.
Exactly. If you have ash, soot, or sweat on your fingers, which you absolutely will in a fire or a home invasion, the biometric scanner will repeatedly fail to read your print.
This is why any reputable biometric lock absolutely requires a concealed physical override key.
Always. Which brings us to standard key locks. And we should elevate the discussion past just people lose keys.
Right. The mechanical vulnerability of a standard pin tumbler key lock on a safe is severe. They are highly susceptible to lock bumping, impressioning, and unauthorized key duplication.
Someone with a bit of knowledge and a blank key can decode a simple tumbler lock without leaving a single trace of forced entry.
Here's where it gets really interesting. What happens when the system actually fails?
It happens all the time.
Let's say the electronic keypad melts in a fire, or the mechanical dial seizes up from decades of neglect, or an estate executor just doesn't have the combination. How do the absolute professionals actually get into a TL15 or TL30 safe without destroying the hundreds of thousands of dollars in valuables inside?
That is where the true art, science, and patience of master locksmithing come into play. The technical manuals we review detail the professional methods used to gain access.
And it is a fascinating contrast to the disastrous brute force DIY attempts you see online.
Oh, night and day. Professionals always prioritize non-destructive methods first. This isn't just picking a lock. It involves robotic auto dialers that run through thousands of combinations overnight, or manual manipulation.
I was fascinated by the manipulation aspect in the sources. It's not like the movies where a guy with a stethoscope simply listens for a click.
No, not at all. True manipulation is about tactile feedback. A master safecracker is feeling for microscopic imperfections in the machining of the wheel pack.
They're mapping the internal dimensions of the lock on a graph.
By feeling how the dial creates slight friction at specific contact points, it can take hours of immense concentration.
And if manipulation doesn't work, the documentation highlights borescopes. It's almost like performing laparoscopic surgery on a safe door.
That is a perfect analogy. A locksmith will drill an incredibly tiny, precise hole, often straight through the dial ring itself, and insert a fiber optic camera.
This allows them to visually inspect the internal mechanisms and read the gates of the wheel pack directly.
Bypassing the need to guess the combination entirely.
But when non-destructive methods aren't possible, they move to destructive methods.
Right. Now, destructive sounds chaotic, but it is strictly calculated. We're talking about precision drilling.
They use a specialized magnetic drill rig to mount onto the face of the safe.
And heavy-duty tungsten carbide drill bits. They have to constantly lubricate them to prevent them from melting.
All to create a single quarter-inch hole based on a highly specific manufacturer template.
They're aiming for the exact shear line of the lock, or the specific wire controlling the solenoid.
And once opened, that small hole is tapped, threaded, and filled with a hardened steel taper pin, putting the safe perfectly back into service.
Which brings up a very direct and important point for you listening right now.
Yes, never, ever try DIY safe cracking. Seriously. If you lock yourself out and decide to take an angle grinder or a heavy drill to your safe, you are going to hit a hard plate.
Which is specifically designed to shatter your drill bits.
Worse, if you use a cutting wheel, you risk throwing sparks directly into the interior. You could spark a fire inside the safe and instantly incinerate the exact sensitive documents or family heirlooms you were trying to protect.
It's a very fast way to lose everything.
If you ever find yourself locked out of your safe, whether the dial won't turn, the code won't work, or you forgot the combination, don't reach for a drill, call West Point Locksmith at 310-295-4040.
Let the pros handle it.
Exactly. They offer emergency safe access, combination changes, vault maintenance, and precision safe opening. From emergency lockouts to rekeying, smart locks, and car key replacements, these five-star professionals serve all of Los Angeles 24/7.
If we connect this to the bigger picture, the challenges of locking a personal safe actually perfectly mirror the massive logistical challenges of securing an entire commercial building. Well, when we pivot from a 500-pound box in your closet to commercial access control and building safety, we hit the fundamental tension in physical security.
Which is?
Keeping bad guys out while letting people safely escape during a fire.
It's a massive contradiction when you really think about it. You want a door to be a solid, impenetrable wall from the outside, but it needs to be as easy to open as a bead curtain from the inside.
Exactly. And from a liability and regulatory standpoint, the law heavily and rightfully favors life safety over security.
The California Building Code from our sources is incredibly strict on this.
It explicitly mandates that egress doors shall be readily openable from the egress side without the use of a key or special knowledge or effort.
Which severely complicates security.
Absolutely.
It makes total sense for safety until you're the IT manager trying to secure a server room full of million-dollar proprietary data.
Right. You want a heavy deadbolt on the inside to keep corporate espionage at bay. But the fire marshal tells you the door basically needs to open with a simple push so no one gets trapped if the servers catch fire. Precisely. That tension is where commercial access control systems become incredibly complex. You can't just slap a mag lock on a door to keep it secure.
A standard maglock holds a door shut with 1,200 pounds of electromagnetic force.
If a fire breaks out, you can't have a panicked crowd trying to pry open a magnetically sealed door.
So, to comply with fire codes, integrating a maglock requires an intricate web of fail-safes.
You have to install passive infrared request to exit, or REX, motion sensors above the door.
You need panic bars equipped with internal microswitches.
And crucially, those locks must be hardwired directly into the building's fire alarm control panel, or FACP.
So the moment a smoke detector trips or a pull station is activated, the relay drops the power to the magnet and the door automatically unlocks for emergency egress.
And pulling complex low-voltage wire through the walls of an existing commercial building, while integrating it with legacy fire alarm panels, is never as easy as it looks on a blueprint.
Never. There are always structural surprises.
Always. And that level of integration brings a significant financial reality check, which is vital if you're a business owner budgeting for these systems.
The technical pricing guides highlight a hard truth. The per-door price on an initial quote is just a starting point.
You must always plan for a 10 to 15% contingency budget for hidden access control costs.
You might run into unexpected electrical upgrades, require asbestos mitigation in older ceilings,
Or face complex network hardware compatibility issues when tying proprietary locks into a localized fire panel.
It adds up incredibly fast.
It does, which is why the architectural guides suggest a very specific strategy: threat stratification.
Meaning you don't put the most expensive lock on every single door.
Exactly. Reserve those highly expensive, heavily compliant biometric locks and mag locks for the 2 or 3 highest risk areas in a building like the server room or a secure records room.
And for the rest of the facility.
Use standard electrified strike plates with encrypted card readers. It balances the exorbitant cost of installation and fire code compliance with the necessary practical level of daily security.
And navigating those fire codes, the FACP tie-ins and maglock compliance is absolutely not a DIY job for a building manager. West Point Locksmith ensures all electronic hardware, electrified strike plates, and maglocks are strictly compliant with building safety codes. With 5-star reviews, they are the trusted experts serving all of LA. Need a consultation? Call them at 310-295-4040.
So after all of that, how do we tie this together?
So what does this all mean? Let's distill this deep dive down for everyone listening.
First, the most critical takeaway is that heavy steel does not equal fire protection.
All right. A TL30 burglary safe is a fortress against power tools, but a 1,000-degree fire demands a specifically rated fire safe with moisture-based insulation to keep your vital documents from turning to ash.
Second, while electronic locks offer incredible convenience, they have severe vulnerabilities to heat and power failure.
Whereas the classic mechanical dial is practically immune to environmental destruction, even if it is harder to open when your adrenaline is pumping.
And finally, whether you're dealing with a small personal safe or a commercial building's main entrance, true physical security always requires a balance with safe emergency exiting.
It's a delicate, heavily regulated balance.
Which actually raises an important question, and it's a structural paradox I want to leave everyone with today. The concept of the override.
The override.
Yes. Throughout our entire discussion today, we've seen that every highly secure system, from the biometric gun safe in your bedroom to the 1,200-pound commercial magnetic doors at your office, requires a physical override key, a back door, or a fire alarm drop.
Because security, by legal definition and practical necessity, can never be absolute.
Exactly. There must always be a built-in vulnerability to ensure people don't get trapped or permanently locked out. So my question for you listening is this: does knowing that every impenetrable security system has a built-in back door make you feel more secure or less?
Wow. It's a brilliant paradox to leave off on.
Yeah.
We spend thousands building fortresses, but we always have to hide a structural key under the proverbial mat for the sake of life safety.
It really changes how you look at every door you walk through.
And every lock you trust. Thank you for joining us on this deep dive. I highly encourage you to go check your own safes today, verify those fire ratings, and keep your valuables truly protected.
Stay safe out there.
Until next time.